Okay, so for today, tomorrow, and Monday, we are going to learn what's called scientific notation. Okay. So what I want to show you real quick. What page are we on? 17. If I take 25 squared times 25 times 25 times, and I just keep making these numbers bigger and bigger. Do you notice how all of a sudden I have a decimal with this like E11? Okay. So it goes from like this number, and then I multiplied by 25, and it was like, what? Now 6.1, blah, 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 blah. What the heck? Has this ever happened to you on your calculator where it gives you this really weird decimal with that E? Oh, okay. Well, if your numbers get too big or too small, your calculator is going to put it in scientific notation. Okay. So scientific notation is a compact way of writing very small or very big numbers. Okay. Like, I want you to look at these numbers down here that we have in our examples. Like, look at this number right here at the very bottom. Do you see how obnoxious that is?
Which one? Oh my god.
Pretty obnoxious, okay? Jeez. So scientific notation is a way for us to write obnoxious numbers that are really small or really big in a way that doesn't take up as much room. Okay. So what we're going to do is we are going to write numbers that look like this. Okay. We're going to have a number times 10 to an exponent. Okay. And that number needs to be between 1 and 10. Okay. So we're going to do some work with moving a decimal. Okay. So I just kind of have a question for us. If I write numbers over here. Right, stand up. In this first number, can you point to me where the decimal is? Point out to everybody. Like, stand up, point it out. I know, this seems silly, right? But you need to wake up a little bit. In number one. There's the decimal point. Okay. Tyler, get up here. Point out the decimal in number 2. That's Tyler. You're Tyler, right? Is that your name? Just point and point to the decimal. Okay, thank you. Okay, Corin, get up here and point to the decimal in number 3. Oh, is that where the decimal is? Is she right? Okay, so if we don't see the decimal, we know it's there. Okay, cool. So this is what's going to happen. We are going to move the decimal either to the right or to the left so that our new number is between 1 and 10. Okay. Then we are going to write using the power of 10. So however many decimal places we move, that is what the exponent of our scientific notation is going to be. Okay. Okay. So we are either going to move our decimal place to the left, or we are going to move it to the right. If we move it to the left, that means we have a big number. And so our exponent is going to be positive. If we move our decimal place to the right, that means we have a really tiny number and our exponent is going to be negative. Okay, so let's just talk through some exponents of 10 really quick. Okay, so you don't need to write this down. This is just me kind of prefacing. So like, what's 10 squared? 100. Okay, what about like 10 to the 5th power? That's 10 times 10 times 10 times 10 times 10. It's 100,000. Okay. Now, what about like 10 to the negative 3rd? Well, that would be like 1 over 10 cubed, which is 1 over 1,000. Okay. Hey, Brady, when you put 1 divided by 1,000 in your calculator, that's the same as what? 0.001. 0.001, like that? Okay. So it's a small number, right? Okay. So when we have these positive exponents, we have big numbers. When we have these negative exponents, we have really small numbers. Okay. The more extreme your exponent is, the more extreme your number is. So if you have like 10 to the 9th, that's a really, really big number. If you have 10 to the negative 9th, that's a really, really small number. Okay, so let's look at this first example right here. First of all, I want you to take your pencil and I want you to, like we're in number 1, make a decimal. Where is the decimal point in 540? It's right there. Okay. What we are going to do, we are going to move this decimal until we get it to a place where we have a number between 1 and 10. Okay. So here I'm going to move it 1 time. Am I there yet? So I'll move it a 2nd time. Am I there? Okay. So I moved our decimal place to the left 2 times. Do you agree? Okay. So now what I'm going to write, I'm going to write 5.4. And you can technically write the 0, but the 0 doesn't need to be there. Like if we have a 5.40, is that any different than 5.4? Okay, so I'm just the same room. Okay. And then we're going to say, okay, but this is times 10. I moved my decimal place left 2. So our exponent on 10 is going to be 2. This is scientific notation. Okay. Why? Brady. What's 10 squared? Okay. So this right here means 5.4 times 100. If you have a calculator in front of you, can you take 5.4 times 100 for me?
540 and then the decimal. If I did that right.
So 5.4 times 100. It equals 540. Which is what we started with, right, people? Oh, well, that's cool. That is what we're doing. Let's try another one. So number 2, go ahead and take your pencil and put it where the decimal point is. Did you put it right there? At the end of the number, okay. If there's not a decimal point, we put it after the last digit, okay? So now, I moved it 1 time, is that enough? 2 times? Nope. 3 times? Okay, what about here? Is that one okay? No, because I have 93.7. Let's move it 1 more time. Ooh, now I have 9.3, okay? That 9, that digit is what I want, okay? Now, how many times did we move it? You need to count the swoops, okay? So here's 1 swoop, 2, 3, 4, 5 swoops, okay? So we are going to rewrite this. Now our decimal point is between the 9 and the 3. Now, is it necessary for me to write these zeros if they're in the decimals? We don't need to write those zeros. So we'll write 9.37 times 10 to the 5th power. We moved our decimal left. Always 10. What? Why 10? Does anybody know why 10? Yeah. So when we talk about our decimals, we have tenths, hundredths, thousands, 10,000s. Okay, those are all powers of 10. Isn't that crazy? Okay, so in your calculator, let's just make sure we're good. In your calculator, take 10 to the 5th power. So 10 times 10, 5 times. It doesn't go that high? And then multiply it by 9.37. What? It goes to the same thing? That's great. This is the answer that I'm going for right here. No, this is me just proving to you that, like, why this works. Okay. All right. So how about you try number 3? Let's just see how this goes. Let's just try number 3. So you got to count. So like I always start at, can you take your earpod out so you can hear me? So here's this right here. Here's where the decimal point is, right? So then I count 1, 2, 3, 4. And I would just count until you get to right there. So yeah, you want to get it in between, like basically those first 2 digits is what you're going for. Denise, how many times did you move your decimal? Denise said, isn't it 6? She's unsure. Do you agree that Denise moved it 6? Yeah. Okay, what's your question? Oh, yeah. So we always start, I'm sorry, Denise. We always start right here at the end. And then we count 1, we count 2, and then you count until you get in between basically these first 2 numbers. Yeah. All right, so we count 1, 2, 3, 4, 5, 6 decimals. So I need 1.852. Once you hit zeros, don't worry about writing the zeros, times 10 to the 6th power since we moved it 6 times. Okay. Okay, so just for good measure, let's do number 4 together. Okay, here's our decimal at the end. We need to move it where am I aiming for? What two numbers do I want this decimal to be between? 7 and 6. Okay, so we're gonna go 1, 2, 3, 4 times. So 7.682, the rest are zeros, so I won't worry about writing those, times 10 to the 4th power. Okay. So all of these in scientific notation that had, notice how all of these exponents are positive, because these numbers are fairly big. Now, which number out of these 4 is the biggest? The third one, right? Okay. Now, if our numbers are scientific notation, what's something that we can look for to know that that's the biggest? Because of this 6th power. This guy is moving the decimal place more than any of the other ones. This is going to be the bigger number because it's multiplied by a bigger power of 10. Okay. Of these 4 numbers, which one's the smallest? The first one, because it's multiplied by the smallest power of 10. Okay. Ryan, you good with that? Okay. All right. Now, when we look at number 6, that's a pretty small number. Yeah. Do you notice how it looks different than up here? Okay. So now when we have decimals, we have numbers less than 1. We're going to have to move our decimal the other way. So go ahead and put your pencil on the decimal. Put it on the decimal for number 6. Okay. All right. I'm going to move it to the right 1. Is that enough? A second time. Is that enough? A third time. Is that enough? Now that is enough. Because if my decimal place is right here, then I have 9.82. And we want just 1 digit in front of the decimal place. So we moved this to the right. How many? We have 1, 2, 3 swoops. So we're going to write this as 9.82 times 10 to the, we're going to write this as the negative 3rd power. When we have to move our decimal to the right, sorry, Bennett, it's because we have a really small number. So we need that negative exponent. Okay. If you have your calculator, 10 to the negative 3rd means 1 over 10 cubed. And we know 10 cubed is 1,000. So take 1 divided by 1,000 and multiply it by 9.82. Take 1 divided by 1,000 and multiply it by 9.82. That's so great, isn't it? I love it. Okay. All right, let's talk about the next one. What number is this? Number 7. Okay, put your pencil on the decimal point. Everybody put it there. Okay, which way are we going to move it? All right, okay, is 1 time enough? Okay, let's move it a second time. Is that enough? Because now we have 5 point blah, 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 blah. Okay, so we moved this only 2 swoops, right? So 5.273 times 10 to the negative 2. We have a small number. When we have a small number, our scientific notation is going to be negative. Okay. All right, you try number 8. Quinlan, where am I aiming for this decimal to be? In between what digits?
1.
We need the decimal between 1 and 4. So we have 1.4. Quinlan on that part. Okay. Times 10 to the, Trent, what's our exponent?
6.
Positive or negative? -6. We have a teeny number, so we need that negative exponent. Okay. Did you get there? All right. So now let's go to number 10. Just before I get started, I'm aiming for my decimal to be between what? 7 and 2. So I'm going to put my decimal. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. We moved it 9 swoops. So 7.25 times 10 to the negative. Whoa, buddy. Okay, so now let's talk about these 4 numbers. Of these 4 numbers, and can we just say colors? All right, so we have purple, red, green, and pink. Which one is the smallest number? Pink is the smallest because it has the most negative exponent. But red is the biggest because it has the least negative exponent. Okay, so do you see what I'm saying about extremes? Up here, orange was our biggest because 6 was the highest exponent on the scientific notation. Okay. 2 was the smallest because it was the smallest exponent. Well, when we're in the negative numbers, we kind of have to think that same way, but with negatives. This -2 was our biggest number, but the -9 was our smallest. Okay. So this is what your homework's going to be, and I'd like to give you time to work on it because you're going to have to do some ordering of numbers. Okay. So I would like you to do page 20. Okay. I will warn you that, like, if you have a friend on the lightning team, I think they're doing like a different page for homework. I don't know if you do homework with other people. I don't think you do. But page 20 is what I want you to work on. And you have 9 minutes to work on it right now. If you get done with your homework, then you can start working on quiz corrections.